Symmetric encryption provides fast, efficient encryption. However, it requires both the sender and receiver have the same shared key, which can be a problem in a complex networked environment. Asymmetric encryption is also called public key encryption, and it uses two keys that are mathematically related: a public key that you publish and share, and a private key that you keep private. Scientists developed asymmetric encryption in the 1970s as a need for securely exchanging a secret key became evident. Let's step through the process of encrypting data that only Bob should see using asymmetric encryption. We start with Alice sending a secret message to Bob with plain text input. And now we take Bob's public key and the encrypting algorithm. It then becomes ciphertext. It's sent to Bob, who uses Bob's private key and the decryption algorithm. It then becomes plaintext output. And because only Bob has Bob's private key, only Bob can see the contents. Asymmetric or public key encryption algorithms include RSA or PGP, and you can use either of the keys for encryption with the other key used for decryption. Uses for asymmetric encryption include key exchange, confidentiality, authentication functions, and creating digital signatures. Asymmetric encryption depends on multiplication and division and requires more overhead in terms of CPU usage and may take up to 10,000 times more to perform as symmetric encryption, which only requires simple bit operations. However, asymmetric has better security and is harder to crack. That is why most encryption systems are hybrid, using both symmetric and asymmetric encryption. I'm at this website where we can see an example of asymmetric encryption. Here we're going to use PGP encryption, which is pretty good privacy. You can also use a similar application called GPG, which is GNU Privacy Guard. I'll start here. In Notepad, I've written, "This is a super secret message," but we're first going to have to generate keys. I'll minimize this, and on this web page we can see PGP key generator. Let's go there. And it asks for the email address. My email address, it could be made up, and I'll just put roxy@patra.com. Now we have to have a password in order to get the key, so we'll use something simple, Cleo. Now I'm going to say generate PGP keys. Now here you can see private key and public key. Now understand that the private key should always be kept private and the public key always kept public. But because of this exercise, I'm going to need to save both of them. I'll select that one, which is your private key, and here's the public key. Now let's go to PGP encrypt message. We'll want to put the PGP public key, which we're simply going to use the public key we just obtained. And the message to encrypt will be the super secret message. And we'll encrypt the message. Now there's the PGP message. Now I'll select this and decrypt the message. Now we'll want to put that message that I just put on there. However, we're going to have to go get that private key. Now here we would need that passphrase, which we kept simple for this exercise, Cleo. And now we'll decrypt the message. So that's how public key encryption works.